Creating tables and evaluating functions. When we evaluate functions, we run into function notation quite often. Function notation is when we replace y in an equation like y equals 3x plus 5, and we say f of x equals 3x plus 5. So what's happening is y is being replaced with f of x. Now this seems like it's making it more complicated, but there's a reason we do this. If I give you an equation, y equals 3x plus 5, and I make a table for that equation, x and y, and I put in some values, 3 times 0, plugging in 0 for x plus 5 is 5, 3 times 1 plus 5 is 8, 3 times 2 is 6 plus 5 is 11, 3 times 3 is 9 plus 5 is 14. So what we do is we take this equation and we change it to f of x equals 3x plus 5. And what this gives us the ability to do is show the x we plug in as well as the y that we get out. Observe, if I ask you to take f of 0, that is x, and that means replace x with 0. It's 3 times 0 plus 5, which is 5. Notice how x is 0 and the y we get out is 5. So when I say f of 1, that means my x is 1, and I'm going to plug in 1 in the equation, and it's 3 times 1 plus 5, which is 8. Notice that x is 1 and y is 8. And if I ask you for f of 2, that means that my x is 2, and I plug in 2 for x, and I say 3 times 2 plus 5, which is 11. And x is 2 and y is 11. Now notice, look at the equations and look at the table. So right here I see that x is 0 and y is 5, and there it is. Here I see x is 1 and y is 8, and there it is. X is 2 and y is 11. That's the third row in the table. So if I ask you what f of 3 is, you already know it's in the table. It's 14. And again, this is the x and this is the y. And what we can do is in one equation see the x we plug in as well as the y we get out. And that is one of the purposes of function notation. Let's look at some examples. F of x equals negative 3x minus 2. Let's find f of 10. That's my x. So I'm going to replace x with 10. It's negative 3 times 10 minus 2. So f of 10 ends up being negative 32. Here's another equation. F of x equals the opposite of x plus 3. Let's find f of negative 5. F of negative 5 is, now careful, this is separate from whatever x is. It's the opposite of negative 5 plus 3. This was my x, and whatever I get out is going to be my y. Well, the opposite of negative 5 is 5, and 5 plus 3 is 8, and that 8 is my y. So f of negative 5 is equal to 8. The x I plugged in was negative 5. The y I got out was 8. If we take an equation with an f of x, we can build a table for it just like we do with a y equation. F of x equals 1/2 x plus 2. Notice I'm picking even values. That's just a little bit easier to plug in. So if I ask you what f of 2 is, it's 1/2 times 2, that's my x, plus 2. 1/2 times 2 is 1, and 1 plus 2 is 3. F of 4 means that I'm going to plug in 4 for x. That's 1/2 times 4 plus 2. 1/2 times 4 is 2. 2 plus 2 is 4. And lastly, f of 6 would be 1/2 times 6 plus 2, which is 3 plus 2, which is 5. Notice the patterns in the table. This is always true with a linear equation. You're always going up by a constant or down by a constant. You might see things now asked in a confusing way. They might say, find x when f of x is equal to 10, given the equation f of x equals 3x plus 1. If you ever get confused, remember that f of x is just y. And whenever you feel like it, you can replace f of x with y and say y equals 3x plus 1. If that makes it easy for you, that's perfectly okay. But the idea is that f of x is 10, and this is f of x. And what I'm going to do is replace f of x with 10, and I'm going to find x in this equation. It'll be 3 times x plus 1. I'll subtract 1 from both sides. 9 equals 3x. Get x by itself, divide by 3, and I can see that x is 3. The notation takes some time to get used to, but remember, if you ever feel a need, you can always replace f of x with y, and it's the same thing you've always done. Here's some problems from your assignment. F of x equals negative 1 plus 5x. So we're going to first of all plug in 1. That means we're going to find f of 1. X is 1. That's negative 1 plus 5, and I'm putting 1 in place of x. Well, that's negative 1 plus 5, which is 4. So when x is 1, y is 4. F of 2. That's negative 1 plus 5 times 2, which is negative 1 plus 10, which is 9. So when x is 2, y is 9. F of 3 is negative 1 plus 5 times 3, which is negative 1 plus 15, which is 14. So when x is 3, y is 14. And lastly, f of 4 means I'm putting in 4 for x. That's negative 1 plus 5 times 4, which is negative 1 plus 20, which is 19. Reminder, domain is the x, and range is the y. So looking at the table, this is the domain, and this is the range. Now, we use set brackets when we write domain and range, but they're already there for us, so we just need to put the numbers in. This is, and separate them by a comma. 1, 2, 3, and 4. And then we get 4, 9, 14, and 19 for the range. This example just uses normal y instead of f of x. But if you wanted to, you could put f of x in place of y. Here we're going to find y, and it's negative 2, and I'm going to put in negative 1 for x minus 1. Negative 2 times negative 1 is 2, and 2 minus 1 is 1. My next equation will be negative 2 times 0 minus 1. Negative 2 times 0 is 0, and 0 minus 1 is negative 1. And then the last one will be negative 2, and I'm going to plug in 1 for x. So that's negative 2 minus 1, which is negative 3. Then we'll plot those values. The values are negative 1, 1, negative 1 for x, 1 for y. 0, negative 1, that's 0 for x, and negative 1 for y. Remember, that's the x-axis, and that's the y-axis. And the last one is x is 1, and y is negative 3, so down to negative 3. Use your line tool and graph your line. Here's an equation in what's called standard form. We're going to talk more about this later. But standard form is when the variables are on one side and your number is on the other. Standard form is really good for finding x and y intercepts where the line crosses the x and y axis. And again, we're going to talk about that later. But you can work with it like this. What you'll see is that it's actually easier if you solve for y. For one example, let's use the equation in the standard form. It's negative 3 times x, so I'm going to put in negative 2 times negative 2 minus 2y. I don't know what y is. I'm going to find y equals negative 4. Well, this is 6 minus 2y equals negative 4. To get the y by itself, we subtract 6 from each side, and negative 2y will equal negative 10. Now we can divide by negative 2 to get y by itself, and y will equal 5. Let's take this equation, which is in standard form, and solve for y. That creates an equation called slope-intercept form, which we're going to talk about later. The idea I want you to understand is that usually solving for y creates an equation that's easier to work with. Get y by itself. So this equation, negative 3x minus 2y equals negative 4. I'm going to get y by itself. First thing I do is get negative 2y by itself, because the last thing I'm going to do is divide by negative 2. So first, I'll get rid of the negative 3x by adding 3x to both sides. Careful on the right side. You cannot add those. They are not like terms. Usually what we do is we put the x in front. If you wrote negative 4 plus 3x, that's okay. But the preferred way of writing it is usually 3x minus 4. We just put the 3x in front. It's positive and the 4 is still negative. That's why it's minus 4. Get the y by itself. Divide by negative 2. And y will equal, I'm going to move the negative up top, negative 3 halves x, and notice it's negative 4 divided by negative 2. That's positive 2. Let's use that equation to finish the table. We'll plug in 0 for x. That will be y equals negative 3 halves times 0 plus 2. That looks confusing, but anything times 0 is 0, so that just ends up being 2. So y equals 2. For the last value for x, we'll take this equation, y equals negative 3 halves, and for x, we're going to plug in 2 plus 2. The 2's cancel, so it's negative 3 plus 2, which is negative 1. We'll plot our values. They should all be on a straight line. These are linear equations. Negative 2, positive 5. 0, 2. And 2, negative 1. Use the line tool to draw a line through those points. Just click 2 of them and the line will automatically form, and you're good. This example's a lot like the last example. It's just in a context. The Auburn Parks Department is planning a canoe trip for middle schoolers. They know they will have enough adults from the Auburn Parks Department to fill 3 canoes. So they need 3 canoes for the adults. Each canoe, that's C, can hold 2 middle school students, that's S. In order to determine how many canoes they need for the trip after having middle schoolers sign up, they plan to use the function C equals S over 2 plus 3. The canoes equal the number of students divided by 2 plus 3. Complete the table using the function above and determine the number of canoes needed for different numbers of students. The first value in the table is S is 4. So our equation becomes C equals, we're going to put in 4 for S divided by 2 plus 3. 4 divided by 2 is 2. 2 plus 3 is 5. So C would be 5. Next one would be C equal, plug in 6 for S. 6 divided by 2 plus 3. And 6 divided by 2 is 3. 3 plus 3 is 6. What if S is 8? Then C will equal 8 divided by 2 plus 3. 8 divided by 2 is 4. 4 plus 3 is 7. So C would be 7. What if S is 10? Then it's 10 divided by 2 plus 3. 10 divided by 2 is 5. 5 plus 3 is 8. Notice the patterns in the table. That's because this is linear. We're going up by 2 on this side and by 1 on that side. Let's graph it. 4, 5. S is my X and C is my Y. So this is S for students and this is C for canoes. 4, 5 would be over 4, up 5. 6, 6 would be X is 6 and Y is 6. 8, 7 over 8, up 7. And 10, 8 would be X is 10 and Y is 8. In this problem, you're just graphing points, plot your points, and you're done. A little review from the last lesson. Remember that domain are the X values. Range are the Y values. The independent variable, that's X, means you can plug in any number you want for X. The dependent variable, that's Y, it depends on what X value is plugged in. Y depends on the X you plug in. Domain is the input, the numbers you put in the equation, and range is the output, the numbers you get out of the equation. So let's read the question. All of the following are true except one. Identify the false statement. The dependent variable is a function of the independent. That's true. The dependent variable depends on the independent. The phrase independent variable means input. Yes, independent means you can put anything in you want. The phrase dependent variable means output. Output is the dependent because it depends on what you put in. The input is determined by the output. That's backwards. The output is determined by the input. What you put in determines what you get out. So this one is wrong. You may have learned this in science. In science, the independent variable is the manipulated variable. That's the term I've heard a lot in science. Either way, whether you call it independent or manipulated, it goes on the x-axis. And what we put on the x-axis describes what's happening on the y-axis. So the independent variable, it describes y. The dependent variable on the y-axis responds to x. So read the question and think about which variable describes the other variable. Let n be the number of people in the water park. When the temperature is F degrees Fahrenheit, identify the independent variable and the dependent variable. Which one describes the other? Does the number of people describe the temperature? Or does the temperature describe the number of people? Well, actually, you could probably do it either way, but often one is better than the other. What I've noticed is that when it's warm out, you're more likely to see people outside doing anything. So temperature describes the number of people at the water park. When the temperature is hot, the water park sees more visitors. So temperature is the independent. Temperature is Fahrenheit. So again, on question 10, which variable describes the other? The one that describes the other is the one that goes on the x-axis. It's the independent variable. Let H be the height in inches of a girl and A be the age in years of the girl. Identify the independent variable and the dependent variable. Well, does her age describe her height, or does her height describe her age? Which one would you put on the x-axis? Age ought to describe the height of a person. So the independent variable is A, the age, and the dependent variable is H, the height. Here's a couple of examples where you're just plugging in values. What's f of 2 when my equation is 10x plus 1? Remember, this is x. F of x is equal to 10x plus 1. So when x is 2, it'll be 10 times 2 plus 1, which is 21. If f of x is equal to negative 2x plus 3, and you're asked to evaluate f of 6, that means x is 6. And that's negative 2 times 6 plus 3. Negative 2 times 6 is negative 12. Negative 12 plus 3 is negative 9. So y is negative 9. Here's an equation with an exponent. In this case, we're going to plug in x is negative 1. So it'll be f of x, f of negative 1 equals, wherever there's an x, I'm going to put a negative 1. And you need parentheses. It'll be 2 times negative 1 squared minus 2 times negative 1 plus 6. Well, negative 1 squared is negative 1 times negative 1, which is positive 1. 2 times 1 is 2. And this is minus 2 times negative 1, which would be a negative 2 times a negative 1, which is plus 2, plus 6. And this ends up being 10. So f of negative 1 is 10. And you'll love this next one. Evaluate f of 6. Remember that when you say f of 6, that's f of x, meaning that x is 6. So along the table, x is 6. And what would this be? Well, this is y. So y would be 34. Estimate f of 3. F of 3 is f of x. In other words, x equals 3. Remember that y is the same thing as f of x. So we're really trying to find y in this case. Right? F of 3 would be when x is 3, and when x is 3, we're right there. What would y be? Well, it's on the line. It's right that point there. Y would be negative 1, and negative 1 is our answer. Evaluate f of negative 2. F of negative 2, that's f of x, and x then is negative 2. So when x is negative 2, you're right there. You're going to go to your line, and that is the point we're talking about. So what is y? Well, y would be negative 3 at that point. Determine x when f of x equals 5. F of x is the same thing as y. They're really saying determine x when y is 5. So go to y is 5. That's right here. Go to your line, and the line is right here. And what would x be? Well, it looks like it would be 2. Last example, evaluate f of 3. So my equation is f of x equals 8x plus 4. F of 3 means I'm going to plug in x is 3 would be 8 times 3 plus 4. 8 times 3 is 24. 24 plus 4 is 28. So f of 3 is 28. So when x is 3, y is 28. Determine x. We're going to find x. when f of x is negative 52. So this is y. We're determining x when y is negative 52. But what we're going to do is take f of x and replace it with 52. My equation, f of x equals 8x plus 4, f of x is negative 52. So that's this. That's the y value. Y is negative 52. So I'm going to put a negative 52 in the y place, equals 8x plus 4. And then we'll get x by itself. Take a 4 off each side. 8x equals negative 56. Negative 56 equals 8x. Get x by itself, divide by 8. The 8's cancel, and x would be negative 7.